So today we're going to look at problem 2.2 in kaleidoscopes, hubcaps, and mirrors. And in this part of the investigation, we're now going to look at how to describe a rotation, or items or objects with rotation symmetry, and how to transform them from their original place to other places where they would be repeated. So we call the transformation that turns a figure about a point matching each point to an image point, that's called a rotation. We've already looked at that in investigation 1, and we've seen lots of different types of rotations and things that have rotation symmetry. So in this problem, we're going to look for a way to describe the relationship between any point x on an image and the point x prime under rotation. And if we just look at the image here that they give us, you can see this image has rotation symmetry. If we rotate it a certain number of degrees, it's going to look the same. Even though the letters will be in different places, the image will still look the same as it is. And so for the first part of this problem, it says to copy this image, the star, and then we're going to do some things to it. So we're going to take the lab sheet that goes with this, lab sheet 2.2A, and already has that copied for us, and now we can just use that to answer questions related to it. So the first part asks us for the smallest counterclockwise turn in degrees. So the smallest counterclockwise, you have to remember that clockwise is to the right, counterclockwise is to the left. So we're asking how far do we have to move this to the left? How many degrees? What's the smallest clockwise turn in degrees that will rotate the star into the position in which it looks identical to this original? And so if you think about it just a little bit, this point A, in order to get it to look like it originally does, we need to rotate it to the left counterclockwise. So from here to there would take us right back to that original position of A. So that's think about that distance, or that how far we have to go there. That's 90 degrees. And if I take my angle ruler and just again go from one point to the next, see that's a 90 degree or right angle to get from A to G. And so that's the smallest possible turn. Now we could have actually started with this point H and thought about from H to F, and the same idea. If you look at this angle in here from H to F, that's a 90 degree or right angle turn. So either way, it's a 90 degree. That's the smallest turn that we can make and still have this original image that we started with. Now, because the original figure has rotation symmetry, the image of each point on the original star is also a point on the rotated star. And so what we're going to do is list the pairs of points and their images matched by the rotation in part 1. So when we had reflections, we had sort of two A's. We had A and A prime. Well, in the case of rotation, we're not really doing that. We're going to actually take A and move it to where G is. And so that would be a pair. A to G is one movement we could have made. Or we could have thought about taking from G to E. That's another pair of points that match up from G to E. If I rotated that 90 degrees, G would be where E is. Or E would move to where C is. And C, point C, this one would move to where A is. Those are points that match up, or points that would be overlapping or in place of the other points. We also have these inner star points that would do the same thing. H would move to where F is. So list that, H to F. And we would have F moving to where D is. And D would move to where B is. And B would move to where H is. And so each of those points would take the place of another point under rotation. If I spin this object around, and really literally could do that. We could just spin it like this, and you see all of those points that we listed are now in place of the other ones where they were. A is where G was, G is where C was, or E was, E is where C was, C is where A was. All of those points shifted around to the left, the number of degrees related to that shift. And so as we think about that, the path that they follow, this path from A to G, this path from G to E, this path from E to C is really what we call the arc of a circle. So, and actually if I took a tool called a compass and I put it on the point of rotation, the center of rotation, and I put it on C, point C, see that there, and I actually make the arc. So if I take this and actually put the line in there, see that arc, and if I just continue on that arc, see the arc, that circle, all the points on there are actually points at which I could rotate this, and any of those, any point on that circle, that arc, would have given me a place that I could rotate this. So if I'd moved A to any point on that circle, any number of degrees, all the way back around to 360 degrees, I could have rotated this image on that. Same thing with the inner set of stars. You can think of the arc between these. If I just draw the arc in there, or the circle, and can continue it all the way around. But I'm just going to stop there. You can see that that's called the arc of which that rotates. So if I want to rotate this image, that path is called the arc. And the relationship among any point X, its image and the center of the star compass can be described by the angle of rotation that we use and the arc through which it passes. So if I'm talking about a 90-degree rotation, I'm talking about along this arc, 90 degrees to that point, from along this arc, 90 degrees to this new point. So each angle of rotation, or each part, each point is rotated to a new point along this arc, along this arc, along this arc, depending upon the number of degrees that I rotate it for it to have symmetry. Now, in this particular case, each of these 90-degree rotations gives me a new point where this image now appears as it originally did. So in this case, there's actually 4 rotations, 1, 2, 3, 4 rotations to get back to the original image. And so based on the center of this image and its point of rotation, the segments connecting them form a 90-degree angle, and the path that they follow for each vertex forms an arc of a circle. So the segments connecting the vertex or its image to the center of rotation are the radii of the circle. They're these radiuses. So this arc is attached to the center. G is attached to the center by this radius of the circle. So you have all these, a radius here, radius here, radius here. They're attached to the center of rotation. So remember that point there is called the center of rotation. And the arc at which they travel through, depending upon which points you begin with, are how that point travels from one point to the next of rotation. So that takes care of problem, at least in terms of explaining what we're seeing in problem 2.2 part A. We'll go on to problem 2.2b in the next lesson.